Okay. So my first example here. Zinc plus nitrate ion. And on the other side, we're going to have zinc ion and ammonium ion. And then I would go ahead and I would assign those oxidation numbers right away. So let's get those oxidation numbers assigned. So what's zinc going to be? Yep, 0. Then what's going to go on in this one here? -2, so grand total of -6. So what's nitrogen got to be here? +5. And then zinc, it's already told us it's +2. And then we just got to do it here for the ammonium. So hydrogen's got to be a +1. It's grand total of +4. So what's nitrogen then? -3. Okay, so we got our oxidation numbers assigned. And if you're following along with the steps, which I suggest you have out, highly suggest, we're on to split the reaction into 2 half reactions based on changes in oxidation numbers. So which one, what's our oxidation reaction here?
Zinc.
Yeah, zinc is being oxidized. It's losing electrons. It's losing electrons, so its charge gets more positive. So that's our oxidation. And then, just by default, then, nitrogen has to be our reduction. And that does follow the reduction rules. Reduction is a gain in electrons. It's getting more negative. In fact, this one's getting so negative, it's actually a negative number for an oxidation number. Sometimes it'll just get less positive, but in this case, it's getting actually all the way negative. Okay, then we got to rewrite. And remember, the only oxidation numbers you guys have to put on there are just the ones of the elements that are being oxidized or reduced. So we can ignore the rest of them. We don't have to worry about that oxygen, about that hydrogen. We're going to handle that later. All right, what's our next step? The oft-forgotten step here. Balance them. In this case, they're balanced, right? Zinc, zinc. 1 zinc, 1 zinc. 1 nitrogen, 1 nitrogen. Oxygen, hydrogen, we don't worry about those because they're not being oxidized or reduced. So we're just kind of leaving those alone for now. So, got step 3, and now we're into step 4. Add the total number of electrons lost to the right side of the oxidation half reaction. Add the total number of electrons gained to the left side of the reduction half reaction. Or, the easier way to think about it, add electrons to the more positive side of each half reaction. So in the top one, where are we going to add electrons and how many?
2 to the right side.
2 to the right side. 2 electrons on the right side. On the bottom one, where are we going to add them?
1 to the right side.
They have to be opposite, yeah. So that's one clue here. They have to be opposite. What's the difference in charge here? We got +5, -3, so how many electrons is that going to be different? 8. 8 electrons difference. It's a difference of 8 in charge.
What?
So we got -3 and +5. The difference is 8. So we need a charge of, we need 8 electrons to balance that. We always add electrons to the more positive side. We want to have it match the charge on the less positive side.
So the little numbers like this, is not like the electron charges in the top right corner doesn't really affect it.
Nope, it doesn't. Yeah, so the charge of the ions doesn't affect it at all.
Okay.
Okay, that's a good question. Okay, so now we're on to step 5, where we have to balance the oxygen by adding water where needed. Top reaction, not needed. Bottom reaction, where should I add waters?
3 to the right.
3 to the right. Okay. On to step 6. Balance hydrogen by adding H plus where needed. 10. Yeah, we're going to have to add a total of 10. So we both have to include the hydrogen that's in the water as well as the hydrogen found in any compound. So a total of 10 hydrogens. Okay, so that takes us through step 6. And now on to step 7. Find the lowest common multiple for electrons. So what's our lowest common multiple here?
2.
I suppose it is. We basically want to make these numbers match, right?
Yeah.
So what can I do? What can I? Yeah, we multiply this one by 4, and it'll end up being 8. So if these numbers are not divisible by each other, that's where they multiply them by each other. But in this case, since 8 is divisible by 2, we're going to multiply the stuff up here to make this 8. So we're going to multiply everything on the top by 4. So now this is 8. This becomes 4. And this becomes 4. And now our electrons are in balance. This takes us to step 8. Cancel electrons, then hydrogen, and then water where possible. So we got our electrons balanced, and now we just cancel them off. They're done. We just use them to get everything in balance. Can we cancel hydrogen ions? No, we can't because we only have H plus on this side. It doesn't count that it's inside compounds over here. So, and then how about water? Any waters over here? Nope, so no cancellation. And now we're just on to the rewrite step. So we just write everything that's on the left in both reactions. And then everything that's on the right in both reactions. And again, if we wanted to have a sub-step, like an extra step on here, double check. Yeah, we could double check everything's balanced. So 4 zinc, 10H, and 4 and 6, 10H. Whoops. Did I forget something? Oh, I know what I did here. I don't need that 5. I put the +5, the oxidation number from top. So, okay, we're good to go there. And, yeah, our oxygen matches up. So, that's why we double check right there. Not just for students, double checking. Good for instructors as well. Okay, so that's an easier one. So the reason why I introduced this one to you guys is just so you can see the effect of having hydrogen and oxygen found inside the compounds. You guys ready for the hard one?
No.
No?
Yeah.
Well, we're doing it anyways. So here it comes.
Are you going to be grading these harshly on the test? These are like really easy tests.
I grade them, well, I do partial credit on them. That's why, like, if you guys notice in the calendar, there's a video day, the day after the test. These ones take me so long to grade, it takes me an entire whole day to grade them, basically. So that's why you're having the video the next day, because it takes me like 4 or 5 hours to grade all your tests after this one.
Wait, all of our classes though?
Since there's 4 classes, it'll take me basically, I don't know, it takes me over an hour per section to grade each test, so it takes a little while. Okay, here's the tough one. So if you can do this one has everything in it. So if you can do this one, you can do any of them. Let's go ahead and get that copy down. And we'll start getting those oxidation numbers put in there. So oxygen, -2 typically. What's that? The negatives have to go down?
Or like the negative, it would be -6.
Yeah, -6. So then the P's got to be,
And then 6 at the bottom, 3 on top.
yep, and 6 on the bottom and 3 on top, yeah. We move over to the nitrate. Everything here has to equal -1 total because it's a polyatomic ion. So we get -6. Therefore, our nitrogen has to be +5. Then we move over here to our phosphoric acid. Everything has to equal 0, so we got -2, -8 total for all those oxygens. 4 times -2. Hydrogen's a +1, total of +3. So then phosphorus has to be +5. And then lastly on to our NO. No.
No.
No. There we go. Okay, so we got our oxidation numbers assigned. Now it's time to figure out which ones are oxidation, which ones are reduction. So which one is being oxidized? Yeah, the phosphorus, yeah.
How do we know it's getting oxidized?
So remember, oxidation is a loss of electrons. So if you're losing electrons, you get more positive. Since electrons are negative.
Oh, I think I understand this.
Yeah, oxidation is a loss of electrons. And then reduction is a gain in electrons.
The other way you can look at it is nitrate starts with the -1 charge and then it ends positive. Like it ends positive without the charge.
Yeah, that works in this case. Yep. It wouldn't necessarily always work, but it works in this case. More so, you use the oxidation numbers to figure that out. So oxidation is loss, reduction is gain in electrons. So it becomes less positive. Okay, let's rewrite them. Remember, again, you only need the oxidation numbers of the elements that are being oxidized or reduced. Okay, what's our next step? Yes, sir.
What? I can't think of it.
Balance.
Balance. Yep.
Yeah, balance. We're in a balance. Okay, are the top numbers that are being oxidized balanced?
No.
No. What do we got to do? Yeah, we got to put a 2 in front of the phosphoric acid. So we're just caring about the numbers, the ones that are being oxidized and reduced.
Right.
So we don't have to worry about these hydrogens, don't have to worry about oxygens. We're going to hit those up when we balance with waters and H pluses. Okay, and how's the bottom look?
Good.
Good. Bottom's good. All right, now we're on to step 4. We're going to add electrons to the more positive side of each half reaction. So, what's the more positive side in the top one?
The right.
The right. And how many electrons do we have to add?
2.
Now, I'm being tricky here. You have to carry those coefficients and subscripts. So we have a grand total of 10 over here and 6. So we have to add, yeah, you always have to do that. You always have to multiply the coefficients or the subscripts of the ones that are being oxidized or reduced. So yeah, that's going to be 4 electrons there to balance that out. How about on the bottom, where are we going to add them?
Left side 3.
Left side 3. Have you guys noticed that it's always the left side on the ones that are being reduced, and it's always the right side of the ones that are being oxidized?
Is that how it's supposed to be?
That is how it's supposed to be. So just a little pattern. I think it's just easier to remember, though, the side that's more positive you add electrons to. I think that's an easier way to remember it. But anyway, let's move on to step 5. Balance oxygen by adding H2O where needed. Okay, let's look at our top reaction. How many oxygens are on the right?
3. Oh, right.
On the right? 8. How many are on the left?
3.
So what do we got to do? Yeah, we're going to add 5 waters over on this side. Good. Okay, how about the bottom reaction? Where are we going to add waters? The right side, how many are we going to add? 2. We're going to add 2 waters. Now, a lot of people wanted to say 3 earlier, but yeah, there's already an oxygen over here, so we only need 2 waters to finish off, to get the oxygen balanced. Okay, step number 6. Balance hydrogen by adding H plus where needed. How many hydrogen we got over here?
We add 1 to the left side.
So we got 6 here and 10.
Yeah.
10, so we have to add, yeah, we're going to add 4 hydrogens over here. Okay, and now the bottom here, what we got to do? 4 to the left. Let's double check that's all working out. Okay, we got 2. Okay. All right. So what's next, guys? We gotta cancel. Okay. Before cancel, what we gotta do?
You have to find
Oh,
those
right, yeah.
kind of bulbs.
Yeah, at least come in multiple, which is gonna be
3.
3 or 4. So we have to basically just multiply by each other, right? We have to get up to 12. So everything on the top by 3. Everything in the bottom by 4. Okay. Now what's our last step? Now we rewrite. Yeah, no, or not rewrite.
We gotta cancel.
We gotta cancel. Yeah, cancel. Okay. So electrons, they're gone, right? Electrons are gone. How about hydrogens? What are we gonna do there?
There's 4 left on the bottom.
Yeah, there's 4 left over here. Okay, and then how about our Waters.
7 left, top left.
7 left on the top left. You got it over here. Okay. And now we can rewrite. What a mess, right? There we go. Well, the rest of the time is yours, guys, to practice this. So you got until 3:17. Good, solid chunk of work time. Yes.
That's in the back.
That'd be fine, yeah. So groups no bigger than 2 need to be working on this stuff. Need to be working on this stuff.
Here's the bathroom too.
Sure.